Hi, I'm Duncan Erschick. I'm a professor of biology at the University of Massachusetts Amherst, and I'm part of the Geckskin team.
Hi, my name is Crosby. I'm a professor in polymer science and engineering at UMass Amherst, and I'm also part of the Geckskin team. So this afternoon we're going to go through and answer the 5 questions that you sent to us about Geckskin, and then so I'm going to ask them, and then we're going to provide some responses. So the first question is, how were you technically able to implement the ability of gecko lizards to stay on a vertical surface in your development?
That's a great question, Al. What we were able to do, Al came to me, and his lab had already done a lot of work on Geckskin and really established the basic principles of it. But they wanted to know, how do geckos, can we learn something about geckos and maybe apply it to the knowledge about the way Geckskin works? And so we started to do some work and investigation of the gecko adhesion principle. We found, for example, that geckos have this really interesting anatomical system where their toe pads go from muscle into skin, and that is a very unusual arrangement for anatomy, especially for tendon anatomy, and that turned out to be very important for geckos to regulate how stiff their toe pads are, and that's an important principle actually for Geckskin. So we found out that there's a lot of the basic principles that enable Geckskin to work well were also found in geckos.
So the second question is, what material is Geckskin made of? Well, Geckskin is a device. That's the first thing to realize. We can actually, we established a fundamental set of principles when we had the Geckskin discovery, if you will. And so we're actually able to make Geckskin out of a wide variety of materials. But in general, I actually have a piece here. Geckskin has 3 parts. First is what we call a pad, and it's a shiny piece. That's made out of an elastomer, something like a rubber or silicone rubber. That silicone rubber is embedded in a fabric. In this case, this is a 1D fabric or unidirectional fabric of carbon fibers. So they're some of the most stiff fibers that you can find around the world. And then the elastomer is integrated into the fabric, and that whole fabric then gets integrated into this more rigid piece, which we through the tendon, and which we call the rigid piece the skeleton. So these components of a silicone rubber and a fabric that is very, very stiff, these are the key materials that are found in Geckskin devices. So the third question is, where can Geckskin be applied to? And is it something like a very strong tape? So Geckskin can be used for a large variety of applications. So we can actually adhere Geckskin to glass. We can adhere it to inside surfaces like drywall inside a house. We've also demonstrated the ability to hang Geckskin on metal surfaces, painted metal, even some masonry surfaces like outdoor surfaces. So we can apply Geckskin to a large range of materials, but it's not like a sticky tape. So if you feel Geckskin, it's extremely not sticky. And in fact, feels almost like, it's sometimes called dry adhesion. It doesn't feel tacky or sticky at all. And this is very similar to the toe pads of a gecko. When you feel a toe pad of a gecko, it doesn't feel sticky at all. It feels actually very velvety or smooth and dry. So that's what Geckskin can be stuck to. The fourth question, who has already become interested in your project? In what areas of our lives has Geckskin already found its application?
Well, lots of people are interested in Geckskin. We get emails and phone calls almost every day from eager young people and inventors and corporations that are all interested in using Geckskin in many different ways. Anything from just hanging things around the house to space exploration to manufacturing, and you name it, and many, many more. So we're still exploring all the possibilities, and we're really excited to use, to hopefully that in the future Geckskin will be used for a wide range of these kinds of purposes.
So question number 5, what does the future hold for Geckskin, and are you planning to modify your innovation in any way? So the future for Geckskin is rather exciting. So we do have a company that is commercializing the Geckskin technology. Duncan and I are both co-founders, the scientific co-founders of that company, and that company is going to be producing Geckskin devices for a wide range of different applications. In addition to the company that is commercializing the Geckskin technology, Duncan and I are still continuing to do a lot of research on adhesion and on Geckskin principles. Just recently, we just finished a very large project where we were testing some of the theories that developed out of the Geckskin technology development, some of those theories on biology and on learning how lizards and insects develop their morphological systems to be able to use adhesion in climbing. And we are also now starting to think about how can we use those principles to develop new adhesives that can be used in medical applications. That is one of the areas that we're starting to really think about a lot. So I think those are the 5 questions. I had, just while we're sitting here, I had one other question that maybe we should try to answer, because I don't think it came through here, and that is, how does Geckskin work? So I told you how Geckskin materials, or what the Geckskin materials are, but it's not always obvious when I hold up a piece like this of how Geckskin works. And the key here is that Geckskin uses a concept that we call draping adhesion. So we have this pad, the silicone elastomer, can come into contact with a surface and can make very, very close contact at the nanometer and micron length scale, just by being soft. Okay, so the pad, the silicone rubber, is very soft, and van der Waals forces can help bring that silicone rubber into contact. Over larger length scales, the fabric allows us to make a conformal contact without sacrificing the stiffness. So one of the big things that we learned in the Geckskin development was that in order to hold a lot of weight, your adhesive system needs to be very stiff. And this is why we chose materials like silicone rubber and carbon fibers to make these really strong adhesives. It needs to be able to drape and make contact while still being extremely stiff, like carbon fibers. And this is similar to what Duncan talked about earlier in the gecko system, where the tendons connect into the soft pads of the gecko, and the tendons provide the same stiffness like the carbon fibers do here. And I'll just finish by saying these pads are extremely smooth. The pads of Geckskin don't have any hairs on it, very different than all of the other gecko-inspired technologies that have been developed.
Well, Al, that was great. I hope that you enjoyed learning about Geckskin, and we'll be signing off now. Thanks very much.
Okay.
Bye-bye.
Bye.